Okay, so this is 5.1 polynomial functions, and we're going to get into other polynomials other than linear and quadratic. So first, we're talking about the standard form of a polynomial function, which arranges terms by degree in descending order. So from the highest exponent on the variable down to the lowest exponent of the variable. Don't pay too much attention to this. That's all that means, is that the standard form means to go from the highest exponent down to the lowest exponent. So in this first one that they show you, they put the cubic term first, the term with the x cubed, then the quadratic term, the term with the x squared, then the linear term, which is just the x, and then the constant that doesn't have the x. Okay? So that's the standard form. Whenever you're writing a polynomial, you always need to put it in standard form when you're finished for your answer. So we're going to talk about the different types of polynomials and how to classify them or name them. For this one, I'm going to look here at this chart. The degree is the highest exponent on the variables. So when it's 0, meaning there is no x, that's a constant. For example, 5. Okay, that's a monomial because it's only one term. When you have a linear is when it's x to the first. That's in y equals mx plus b form. Okay, it forms a line. That's why it's called a linear. And if it's two terms, then it's a binomial. Okay, the next degree is when it's x squared. It's called a quadratic. Now, a quadratic is normally a trinomial because you have the x squared term, then the x term, and then the constant. But it doesn't have to be. Okay, like this one, for example, only has one term, which is why it's a monomial. When it's x to the third, the degree is 3. It's a cubic. Okay, and this example is a cubic trinomial. And then when it's x to the fourth, it's called a quartic. And this example is a quartic binomial. Fifth degree is a quintic when it's x to the fifth. Now this one has a degree of 4. Anything above a trinomial, you can either say polynomial of 4 terms, polynomial of 5 terms, polynomial of 6 terms, etc. Or 4-term polynomial, 5-term polynomial, 6-term polynomial, and so on. Okay, so you don't have to say it a specific way, but you just say it out how many terms that the polynomial has. Okay. On to the examples. Okay, so here you're going to have to put it in standard form and then name it or classify it by the degree and the number of terms. So the first one, I'm going to start, in order to be in standard form, I got to start with the highest exponent. Let me change my color. Okay, which is going to be the 9x squared. Then I get my x term, 3x plus 5. This is the standard form. Okay, highest exponent down to the lowest exponent. My degree is a 2. So that's, you have to name it. Don't just say 2. Because it's a 2, it's called a quadratic. And the number of terms is 3. Again, give me that name. What it's classified as is called a trinomial. So this is a quadratic trinomial. The next one. My highest exponent here is the x to the fourth. So I start with that. Then I have my x squareds. Now, I have positive 10x squared and negative 6x squared. Because they're the same, I can combine them. So that's going to become positive 4x squared. Then my x term is 4x. And then my constant is negative 12. You see, I put put a different shape or did something different for each term. Everything is accounted for. I've used every one of them. I put it in the right order. So that's the standard form. Now, notice that the cubic term is missing, the x to the third. What that means is there's really, if you ever need to use that coefficient to that, it's actually going to be a 0. So it's really a 0x cubed, but they're not going to write that, okay? It's not going to be written. You just leave it out. So the highest degree is 4, which means it's a quartic, okay? And it's 4 terms, which means 4-term polynomial. So it's a quartic 4-term polynomial. Remember, if you have any questions, write them down to ask in class on Monday. Here's 2 you try problems. Go ahead and pause it, try them on your own, and at the end of the notes I'm going to be giving you the answers to all of you tries all at once, okay? Okay, so I got a joke for you. What did the 0 say to the 8? Hey, nice belt. So tell me that punchline on the way into class on Monday. Give me the punchline. Hey, nice belt, on the way into class, so I know you took the notes. Okay, so if you were in class on Friday, I talked about this a little bit. I'm going to first focus down here at the number of terms of a polynomial. You can tell the number of terms of a polynomial without looking at the graph by the degree, and it has 1 less than the degree. So if the degree is 4, then it has 3 turns. So like on this one, it turns here, here, and there. Okay? Sorry, I couldn't be a little more exact on that, but it has 3 turns, where a quadratic, since it's 2, only has 1 turn. And a cubic, like on this one, has 2 turns because it's a degree of 3. Alright? So, that's the first part of this section, but you also need to tell the end behavior. And I also talked about if the degree is even, then the 2 ends of the graph should be going the same direction, either both up or both down. Where if it's odd, the ends of the graph are going to be going opposite directions. One's going up and one's going down. The hard part is which one is which. Well, you look at the A, like the A is the coefficient to the leading term. So that in this one, this first one, the coefficient to the A is positive 1. So that means because it's positive, the graph is going in a positive direction. The degree is even. They're both going the same direction, so that means it's going up and up. Where in the next one, it's even, so they're both going in the same direction, but the A is a negative 1, which means they're going down and down. Okay? And the next one, the degree is odd. They're going opposite directions. Now, this is where it can get a little tricky. So if my A is positive, so this is a positive 1, I think of it as the graph is going in a positive direction. So from left to right, it's starting down and then it's going up. Okay? Where if that A is negative, it starts from up, but it's going in a negative direction, so it's going down. Okay, so that's the easiest way I can think to explain it other than just memorizing it. Okay, so when I'm trying to describe the end behavior of the graph and the number of terms, all I'm looking at is that first leading coefficient or that leading term when it's in standard form. So I can tell the number of terms because this is a degree of 3 that it has 1 less than that number of terms. So it has 2 turns. And now to tell the end behavior. Since it's odd, the degree, the n is 3, it's odd. I'm looking at my a, which is 4, is positive. That's what's important about that. So because it's odd, they're going in opposite directions, which means it's going, and it's positive, the a is positive, so it's going in a positive direction, and it's going from down to up. Okay? So the way you're going to write this is as the x is approaching negative infinity, the graph goes down. So down, let me restart this. Again, I told you I don't really understand how to edit this, so sorry about the mistakes. The graph goes down as x approaches negative infinity. As the x is going in the negative direction, the graph is going down, and it goes up as x approaches positive infinity. Okay, you can shorten this. Instead of the approaches, you can just say down as x approaches, this is the approaches sign, negative infinity, and up as x approaches positive infinity, and use the arrow as the approaches. Okay, but that's what it means. It means it's as approaches. Okay, try these two on your own, and that's it. Describe the end behavior and the number of turns. So for this past one, this was part of my answer as well. 2 turns, down as x approaches negative infinity, up as x approaches positive infinity. Go ahead and pause it, and on the next page, I'll have the answers. So here are the answers to the U-tries. Number 3 should be a quartic because x to the 4th trinomial, and that's the standard form of it. Number 4, make sure you keep the signs for each term with it. So it was a negative 4x to the 5th, so that negative has to stay with it when you write it first. It was a positive 3 and a positive 10, so that became 13. Sorry, this should have been a squared, 2x squared. You're missing the cubic and quartic term there. Those are both 0 actually. You shouldn't write them though. And that's called a quintic trinomial. Number 6 was 3 turns because it was a degree of 4. And it was a negative, so it was going negative direction, but it was even, which means they're both going in the same direction. So down as x approaches negative infinity, down as x approaches positive infinity. And 7 was a cubic, so there's 2 turns, and up as x approaches negative infinity, down as x approaches positive infinity. Remember, if you have any questions, write them down, and I'll see you on Monday.